University of Dallas in Irving, Texas. And I'm also the coordinator of the Fab Lab. So welcome. This is the third year of a 3-year project. I would like to thank our supporters of the Fab Lab, at West Virginia University and NCECA, of course, Brackers Clay and Scut, and for the last couple of years, Shapeways and the 92nd Street Y. I'd also like to thank David Lippa, who is our AV guy up in the back, and behind every technological presentation, there's a whole nother level of technology, and we really appreciate his help all of these years. Today, I'd like to introduce to you this morning Joe Cam and Keith Simpson. Joe and Keith are both artists and educators, designers, super thinkers, and all-around great people to know. Keith Simpson originally was born in Spokane, Washington, and he was first introduced to ceramics at the Spokane Falls Community College. And he received a BFA in 2010 from the Kansas City Art Institute and an MFA from the Ohio State University in 2012. Keith was a professional mold maker for several years and worked with making molds for several rapid prototyping companies. He also interned at the Matter Factory in Kansas City and was a resident artist at the Archie Bray, which is where I had the pleasure of first meeting him. Currently, Keith holds an appointment at the New York State College of Ceramics at Alfred University as the Raw Materials Technical Specialist and Adjunct Professor of Ceramics. Joe Cam is an artist, designer, educator, and engineer working in and around the field of digital design and fabrication. Joe studied ceramics at the Kansas City Art Institute and New York State College of Ceramics at Alfred University. He has participated in artist residencies around the world, including Hungary, Poland, and Denmark, and currently lives in Kansas City, where he specializes in design and parametric design as a project engineer at Zahner, a fabrication company specializing in architectural metalwork. So today, in this collaborative presentation, they will be discussing their collaborative project, exploring digital tools and methods generating and augmenting ceramic forms, patterns, and surfaces. The goal of the collaboration has been to develop and encourage alternative workflows to ceramic media using well-established systems of computationally driven motion control, including 3D printers and CNC routers. So I will let them explain all of that to you. Here they are, Joe and Keith.
Thanks for coming out. It's really an honor to be able to be part of the Fab Lab for the last few years and be able to have this opportunity to show you guys what we've been working on. And this year, Joe and I kind of came together. The whole theme for this year was the idea of collaboration between a couple different makers. And Joe and I, we met last year. We presented together last year, and then 2 years ago? 2 years ago. Joe, maybe you should take this. 2 years ago, 2 years ago, Joe and I presented together, and in the middle of our co-presentation, where both of us were presenting our own things, I'm utilizing a digital workflow that brings Rhino and Grasshopper in order to generate code for the machines. And it became immediately obvious that Joe really knew a lot more and was a lot more in depth with the Grasshopper part of it. We'll talk a lot about that. So I told him during our presentation that he was going to fix all my problems. He just didn't know it yet. And so here we are 2 years later, and we're working together on this project. And we've been basically working together really a month and a half, like 2 months maybe. We talked a little bit earlier. Today we're presenting to you Ctrl+Alt+Delete, a scripted drama. These are alternative methods for tradition and technology, and we're looking at different kinds of workflows. So here's a little slide of Joe's work. And this is what I knew about Joe, actually, when I did first meet him. I think it was 2008. He must have graduated from Kansas City in 2007. But we shared an instructor. His name's George Timmock. Any Kansas City people here? So, yeah, great. So George Timmock really changed the way that I make work. When I first met Joe, I was working on the teapot project for George Timmock's class, where you carve a plaster block into a teapot. And when I got there, I really planned everything out. My background was in prototyping, so I drew every little last bit of what I was going to make, and then I sculpted and executed and followed it through as best to my original strategized vision. And then something happened with, maybe it's like the tight deadlines or just the air in the studio with the carbon monoxide from the old kilns. I don't know what it was, but somehow like there just wasn't enough time to do the work the way that I was working. I started like looking at the material different. I think we all did, and we started looking at it like as an involved, responsive process to the qualities of the material. So the first time I met Joe, I was working at this carve pot, and I looked out the window, and there was this weird dude out there. And he was juggling this spindle. I don't know what it's called. What is that called?
Diablo.
Diablo?
Yeah.
So you're juggling the devil, this spindle with a string and two sticks and tossing it in the air. And it was a really weird thing. I was like, who is this guy? I started asking people around the studio. And they're like, that's Joe. As though that explained like who this guy was outside the window dancing around. He came in later and we spoke for a minute, and almost immediately we started this conversation about responsive studio practice. And I was in a groove where I wasn't exercising it at the moment, and I was coming into it. And we keep referencing in our conversation David Pye's, right? The workmanship of certainty versus the workmanship of risk. So what we're looking at, that's part of our studio practice. It's definitely part of my sculptural practice. We're trying to figure out how that finds its way into these digital tools where there's so much legwork in the background. And sometimes you can look at it as though it's just press play. And we're really trying to figure out ways to use the tool differently. So this is what I've been working on my own with these tools. So these are about 10 inches tall. I can print one of these at a time on this scale of machine. And it's a curved, lofted form that's generated in Rhino. And then the patterning that is on it is it's the result of the pump that I have that is iterative. So the pump puts droplets out. So it's not a continuous line. And the patterns, the moire pattern that's happening is circumstantial to the mechanical effect of the machine. I guess a little bit about digital workflow. This is the most rudimentary way to think about it, and this is the way that I got into making my parallel walled forms. This is, on the left hand, you're going to see, this is just a curve that's freehand kind of drawn in Rhino using the curve tool. And then in the lower part, there's a visual reference to Grasshopper, what Grasshopper is and what it looks like. It's really like a visual programming language. Is that a good way to describe it?
Yep.
So I'm really using it in my practice at this point in order to generate the code to the machine. And at the point that I started using it a few years ago, I was using it because the other tools weren't really satisfactory for what I wanted to do. And it was okay to have it really limited because that's a building block to start from, to start understanding the machine and like start understanding like how to talk to it. And I figured out if I could figure out how to talk to one of these machines, there's a whole group of these machines that we could figure out how to talk to and get them to drive them and really get them to do what we want them to do. And then on the right-hand side, what you see is an example of G-code. And so G-code is just a series of coordinate commands, basically, and other things that's sent to 3D printers, CNC machines. It's what tells them how to run. And then this is about my machine and what I'm working with. I really think about the machine as kind of superficial. Like any machine, any number of machines could interpret these commands and like make something. But just so you know what I'm getting into, this was a kit machine that I started out with the graphic drawing in the top, and then what I've Frankensteined into is that larger machine that you see in front of you. And it's most akin to, like what's on the market right now that's most akin to this machine is actually a CNC carving machine called X-Carve that's marketed by a company, Inventables. And that machine could easily be hacked, but you could also hack together your own machine pretty easily. These runners could be parts of a bike, or they could be 2x4s. They could be anything. And so the material that I'm working with is kind of a little bit different. So a lot of people who are 3D printing with clay, they are 3D printing largely with plastic clay. Like clay from the bag, add a little water, put it in your compressed cylinder. And so why am I printing with slip? So I'm using a liquid slurry in this reservoir and pump through the machine. And at home, I can have a much larger reservoir that can keep this thing filled all day. And basically what I'm interested in is having an open hopper system so that this can be filled at any point during the program. So I can continually feed it, and it can just build something larger and larger potentially. The slip can be fed with gravity rather than pressure, which is really a good perk for me. And then removing the weight of the reservoir from the machine means that that I can continuously feed it, and like it can feed a lot more slip. And the machine doesn't have to be as strong, as huge, as expensive, or even like potentially as dangerous, because these machines can be really powerful. The bummer with printing with slips is that when you're printing with a slip, there's more water, so there's more shrinkage in the clay, and there's the potential for like low solids loading, so you end up with inhibiting the grain strength. But I think that sometimes people kind of get hung up on that's slip, that's not clay, or that's clay, that's not slip. It's like every one of these systems, whether it's the machine or it's the dynamics of the fluid that you're working with, whether it's plastic, clay, or a fluid, everything has its own design constraints and uses. So there's like a big window that it's actually really useful in. And so that's what I've been kind of tuning into. And so I decided to share my recipe this year. And this recipe might cause you more headaches than anything else. It might break your heart. It feels like ceramics does that more often than not. But just to say that what I'm using is most akin to like a bisque slip. So it has a low kaolin content so that there can be less water. And then I'm using a lot of fillers. And then I'm also starting to play around with using a dispersant to thin the slip, and then a flocculant to bring it back. So I'm adding dispersant to thin it out so that I can mix it and get the water content low, and then using magnesium sulfate to thicken it and bring it back to the viscosity that I can print at. And it's created. I'll show you the slip, and it has some unique properties. So this is what I've been able to do with it, kind of on my own in my rudimentary understanding of Grasshopper. I've been able to print these large curve-walled vesseled forms that embrace the moire patterning that's intrinsic to the pump system that I'm using. And then I'm able to print open curves as well, like these test tiles that we see in the middle. That's provided an opportunity to print things like handles that can be attached to things. And also the test tile, to be able to like set the machine and run the test tiles, and that's a really great advantage, and also an advantage of having like test tiles that are actually made out of the same material that you're working with. And then I'm starting to work with larger things. So this is on the sculpture plinth that's on the right. That is, it's about 500 millimeters in diameter, so close to, it's like 20 inches, close to that. And then you can see how there's this way of potentially making an extrusion, like using additive and just building, and the height is kind of arbitrary because it can just be extended until until you reach the limit of the material. So I'm able to print right now. I'm able to print multiple forms with my rather crude Grasshopper interpretation for the G code, and what I've done with that is started to make these vessel forms, small mugs and stuff. And I didn't have a resolution for fixing the handles, so I really just glued it on there. There's a few secrets to contemporary ceramics that, the secret to giant sculpture seems to be paper, you know? And then that there's glue kind of all over the place and hidden and cloaked. So I really wanted to use glue and just highlight and show it. And I tried some different colors and decided that I really liked the bubblegum aspect of it. And it's also nice to be able to join things that are native to different atmospheres or firings or temperatures. So it's nice to have like an earthenware handle. The handle's the weakest part of a mug usually. It's like the thing that almost is most prone to break. And then in this system, the handle's made out of the weaker of the two versions of clay even. So I'm able to print multiples, but only with parallel walls. And then I'm able to print single forms with curved walls. And so one of the things when talking about collaborating, we started to talk about what we could get out of it. You know, how do we get something for our own studio practice, and how do we be a good partner in it? And so how do we share? What do we share? This, for instance, this slurry that's being printed here on the left-hand side is straight Lizella. Does Lizella have a table here? Do you guys know Lizella clay? It's fantastic clay, but that's just Lizella. Most of it has been calcined beforehand and then mixed together, so there's no big secret to that recipe, and it actually pumped fantastically well. Okay, so our collaboration. So how do we collaborate in a manner that benefits both practices? And so we had conversations over Skype, and we talked about what we were interested in, what were the next steps in our own practices. And so I was really interested in streamlining my workflow from design. I'm kind of interested in thinking about this as, can I make studio pottery? Can I 3D print studio pottery? Can that be an effective means of production? And can the mark be interesting and unique? And I don't know what it is exactly, but just trying to figure out as a benchmark for efficiency. So I'm interested in streamlining the workflow for design, from design to production. I was interested in curve sorting for multiples. So that's what I had problems with. That's why I was only able to print parallel walled forms, whereas I really wanted to print multiple curved walled forms. And then other implementations of a multi-axis controller. So we have control of this little machine or this little board that's on here. And it's this little thing, what's that cost, Joe?
That's like a $25 board or something like that?
Yeah, so you have a power supply and a board, but $75, you have something that can control 4 stepper motors.
Yeah.
So we usually use these to do 3D printers, but I mean, there's all sorts of things that we could potentially do with them. We've got this pump system that we'll talk more about, I guess. But what if we just ran 4 pumps? And what if we programmatically controlled them to plot the space between 4 glazes? What if we used it to formulate our glazes, rather than like navigating a material space, rather than navigating a Cartesian space, right? So Joe is really interested in flexible tool implementation. And I think that I can go ahead and say that we're both interested in all of these things. And it's always like, where do you put your priorities and focus at any given moment? And how many things can you really work on at one time? It's a lot, really.
Yeah.
So flexible tool implementation, I think we're talking about changing nozzles. We're talking about putting brushes on machines. Even fixing into that might be a glaze mixing machine, right? But other attributions that could be exploited by this simple set of tools. Script, process solutions, and design strategies. So I haven't used scripting with Grasshopper to generate form yet. I've used Grasshopper exclusively in my own practice to generate the code to make the forms that I'm just drawing in Rhino. And so I'm working with Joe, and we're figuring out ways to script new things. And everything that we're drawing in the machines as we're talking today, and we'll be demonstrating this, we're drawing the tool paths. So it's almost like we're never really drawing the thing. It's almost a different workflow than 3D printing, where you've engineered the geometry of the thing, where we've just we've engineered the paths that would generate the thing, and we kind of don't see it. I mean, there's ways of making visualizers and stuff, but it's not really manifest as like a digital object. It's manifest when it's in the world and real material. So alternative toolpaths too. So why are all of our toolpaths horizontal? And it's not exclusively true. There are people working with other toolpaths and stuff, but like, how do we do that? How do we generate those? And what kind of paths are we interested in? So that everything doesn't have like a horizontal line going through it. especially if we're not 3D printing prototypes. What we are is we're manufacturing a thing that is done in itself. There's not going to be a mold made of it to turn it into something down the line. And then we talked a lot about decorating 3D wares with digital tool sets. So can the machine navigate space and find its way to decorate an object? And talking about different ways of doing that. So all the highlighted components that we have here, really they kind of came together into thinking about, okay, what's a good step to get pointed into that direction? We want to decorate things that are 3D wares. So what we need to do is figure out how to run toolpaths onto a dimensional surface. So, and I'm really interested in what the next kind of object is. So maybe, like, if I can make a plate, and I can make a bowl that's kind of tall, but I can't really make anything that's wide and shallow without the support of the mold. So printing into the mold is a great step in that direction. But none of these things are really the end game. It's like, figure that out and figure out what the next step is, and what doorways does that open?
Okay. Yeah. So
I should set up.
you can set up, yeah, and I think we're switching to my computer
Great.
right now. Okay. Oh, look, it's your workflow. How do we do that? Where are we? Saw that. This is kind of amazing. So when this idea of printing these vertical walls, what I came to understand after looking at Keith's script is that, like usually when you're doing 3D printing, you take your geometry and you make two-dimensional slices of it, and then you're basically like printing each individual slice on top of each other. But the way that Keith figured out to do this, he was printing one layer, and then he was just telling the machine, oh, you didn't actually print that layer. Go a little bit higher and print the same layer. And so he just printed the same layer and as many times as he wanted to make it as tall as he wanted, which is a really effective solution, but it's also pretty limiting because you have to make everything exactly the same. You're just repeating it up in one direction, and that was really the exciting thing about working with curved forms and being able to sort those. But it's a somewhat challenging problem because, like, Grasshopper is really easy to start with, but it starts to get complicated when you have to manage all the data to be in like parallel data streams and just get more complicated.
Ignore that. I'm really glad this happened because it doesn't always work. It'll come to an end.
So when I'm talking about scripting solutions, I'm interested, I mean, all of us are interested in some part of what we do. We want to focus on something, but then we want to kind of ignore another problem. So you might be really interested in glazes, but you want to take your clay out of a box. But for me, a lot of the things that I'm doing are about looking at something and opening up that box, seeing what's inside. And for scripting this solution, this is actually Keith and my kind of first collaboration. It was about a week or two after NCECA 2 years ago. And I think it was your birthday. I wrote you a little like birthday greeting, like, hey, I made you a script.
I love that you saved those. Did you have the quote from the?
Yeah, it's I basically was playing around in Grasshopper, and I was like, oh, this would totally do exactly what you need it to do. So I wrote this little script, and I sent it to Keith, and like, yeah, you just started using it for the basis of your.
Can I just say that it's really great to have like something that streamlines your workflow, that makes something easier, and so you don't have to worry about it. I was using a simple offset curve, so every curve I was generating like by clicks with the mouse, things inside of Rhino, and a big part of my process is to not let not understanding something keep you from making something. So just like do it.
And when I saw that, I was like, oh, well, you're spending a lot of time doing something that's you know how to do exactly, and you're not really gaining anything from doing it. And so if you can make a scripted solution for that, you can forget about it. It's the same way as like opening up that box of clay. If you're not really interested in mixing clay, then put it in a box, forget about it. And so this is an example of that, creating a solution that you didn't have to worry about anymore. And then this question of sorting curves, like that came up pretty soon after. After I'd done that, we kept in contact. I think it was like December of the same year. And you were like, you know what would be really helpful is sorting curves, because like that's a real problem, and I don't know how to deal with that. And then, yeah, we kind of like fell out of touch a little bit. And it wasn't until like a year and a month later that we actually dealt with that problem. But then we were talking on like Google, Skype, or whatever, and it came up again. And since then, like that was 2 years ago, I've had a lot more experience at my job. At my job, I use Grasshopper almost every day. So we did it in real time. We just got on Skype and we made the script right then. And the important thing about this is being able to tell the machine, like go from piece to piece, but do the first layer all at the same time. And how do you know what's the first layer, what's the second layer, getting all of those separate, and getting them all in order.
How do most people do that for 3D printing?
The program takes care of it.
Yeah, so most people just use like a slicing
Yeah.
program. There's lots of options.
And these are, again, like out-of-the-box sort of solutions. And so this is what we came up with. It was a script. It was kind of messy. But then on the right is the thing that we ended up with. And that's the box. That's the box that you can forget about. And you don't need to know what's inside the box once it works. And this just allows you to put in a whole bunch of things, figure out, do some adjustment to make sure you're getting the right number of things coming out, and then it gives you a visual preview of that. OK, and that's what allowed him to do this. 1 minute? OK, so.
So what we're going to see here is one of the things is thinking about this machine as potentially a way of like really manufacturing something. And so like how do I make a bunch of things at once? The video we're going to see is utilizing Joe's curve sorting in order to do multiple curve-walled forms at the same time. So this is within 24 hours. There are some things we have to get worked out. You'll see variances in the flow halfway through the pot, but the paths are sound. So in 24 hours, the machine continually fed itself, and it printed 12 vases. And this wasn't an isolated run, but I've run this a dozen times, really trying to fine-tune the machine to utilize it. Really look at, you can see how it shrinks as it's drying, like the clay is actually breathing. That's great, though, to be able to make a dozen vases and to have like a flexible enough workflow that it's not like a mold where it's replication of every single form. There's ways of like using this generative processes so that every one is potentially unique. That's not what we have here yet, but we're working on it.
Yeah. OK, we're ready to go on. OK, so the next thing that we're both interested in is this idea of 3D printing into molds. And that's kind of a traditional process as far as like sort of like digital fabrication goes. You know, you mill out a mold and then you'd like cast it in, or you'd cut something out of foam and you'd cast a mold. But actually printing into that mold is really interesting because it's pretty much the same thing that the machine is doing when it cuts it out, because it cuts it out in all of these layers. But then what we're doing when we print it is we're actually refilling in those layers. And so you can think of the machine moving to cut things out, and then the machine moving in almost the same patterns to put stuff back in to recreate those layers. And you can actually use these programs, the same programs that you can use to lay out a cutting pattern you could use for an additive program. But this is one of those questions of like, is this a box that we want to leave closed, or is this the box that we want to open up? And for us, I think it's something that we were both really interested in opening up, in understanding, and in doing some of our own things with that. what do you need out of this kind of program? You need to know that you're going in the right order, that you're doing your bottom layer first, your second layer second, like all of these things that seem really trivial, but they're really important because if you do them in the wrong order, then bad things happen. You have to know that your machine's going to actually go up and move out of the way. There's all sorts of safeties that are built into the software of these machines and the controllers. It's really sophisticated software. So even to do something that seems really simple ends up being really complicated. So this is what we ended up with. This is the script. And it's, we built it out. We've got one script that generates our toolpath. That's sort of the where to go for the machine. And then from there, we're able to check that and then go from the toolpaths to the G code that actually talks to the machine. And that's what took us to this point. So this is, I don't know how many you had done at this point, but
This is what you're looking at is the nervous, hair-pulling edge of what we're trying to do. Like, we have just figured this out, and I've only printed this mold a dozen times, and I still have S-cracks, like things that we're used to seeing with material at the potter's wheel. We still have like these same kind of problems, navigating the material and how that works with the mold. But this is probably like the third time that mold was run. I ran it. I mean, I broke the tip and I ran into the machine, and the nozzle, even the nozzle was like a really primitive, quick solution. It was this nozzle was a 5-minute drive on my lunch break to the local Tinkertown Hardware in Alfred, and just looking at what I could put together that would work as like a proof of concept. And it's worked well enough that we're still playing with it. But there's any number of things that we're trying to kind of resolve and address.
do you want to get your print started?
I think I'm almost there. So I'm going to just prime the pump. G92 is one of my favorite G-code commands if you're scripting stuff by hand, because I've run the pump and now it's moved in space. The numeric value equated to it is increased, but I can say G92A0, and then it's going to tell it that it's 0 again. So I've went ahead and just told it that it's at 0. Can we get my screen up for just a second? I guess there's an interesting difference, too, between the way that I'm sending code to the machine and the way that it's usually done in the 3D printing world. I'm using what's called a terminal, and I guess what's interesting about this is the only thing that it does is it sends the code. So when you send it, it's like if it doesn't work, then that's it. You can't adjust anything on the fly. And Joe's going to be showing us like some alternative method that he's using.
Well, you've talked about changing the voltage. We can
Yes.
talk about that later.
Yeah. I think I'm set. I'm just a little bit worried. I'm nervous today. And then we're going to run, which one did you decide we're going to run? The facet dish.
Yeah.
Okay, it's going. If it doesn't work, then. So what I sprinkled into the mold is cornstarch. That's another secret of contemporary ceramics. Until someone told me about, I didn't figure out the cornstarch. Someone told me, and it just clicked right away when they did. But I was sprinkling malachite into the mold, because I was thinking I could sprinkle silica, and then I'll get silicosis, and then so malachite has like a low silica content, and it left residue on the bottom of the pot. But the cornstarch, it's okay because it just burns away in the kiln. So as long as you have a well-ventilated kiln, it's a really good alternative. The cornstarch is great for, what's that?
Is this what it's supposed to be doing? Does it go all the way up every time?
Yeah, so this is also we could generate a more elegant path. But right now, the path that we have is my G-code script that I generated, and in order to deal with this back bowl that has the hump in the middle, where the path, it starts here and then there, and it has to get over this, it goes to a safe Z height that's a centimeter above the mold. So it's not necessarily the most efficient path, but it works.
Yeah, I mean, a more sophisticated program might go through this and say, okay, well, here's where I'm starting and here's where I'm ending. Is there anything in between those two?
Sure.
But that's a kind of like
Yeah.
complex evaluation when you've got hundreds or thousands of different lines.
And the way with printing into the mold, it's like kind of a simple solution to just say, if I go above the 0 point, it's not going to hit anything because all the geometry is down.
So it's just like a safe way of doing that. But I think, were you going to say something else about that?
I don't remember what I was going to say.
That's what happens. Cornstarch, yeah.
Oh, one cool thing about the cornstarch with printing handles, the test tile image that I showed earlier, I'm able to print an extrusion and then stop it, sprinkle cornstarch, and then print another extrusion. So I can print an extrusion that's 10 inches tall that'll pop apart into individual handles that are half of an inch tall, right?
So could you do that with this? Like, could you just print 10 plates on top of
We
each other?
we could presumably do that. Yeah, if we made the paths right.
Yeah.
Yeah.
Cool. I didn't know that. We can
Fire
try
the
that.
whole stack.
Yeah, fire it all at once. So now that we've got that box, like now that we've got this box opened up, now that we've got it working that well, what are the other things that we can do with that? We've just started. It was actually, I kind of surprised you this past weekend. I was like, hey, we could do this other thing.
Yeah.
Because we're really...
It was on our radar.
Yeah,
I mean, we didn't think it would move as quickly.
So can we go back to my computer? Okay, so this is our next thing that we're thinking about. It's like, okay, well, we've done toolpaths that look like what a machine would do, but can we do something that is completely different? Can we get it to just do random shapes, random lines, and have that be part of the design? This is really where I start thinking about, like, how do I make a tool that's actually usable by someone else who may not have the same level of understanding or level of scripting ability? How do I simplify that to make it so that you have the design opportunities?
And this is why we would have, from the get-go, unboxed the toolpaths and not used the toolpaths that we use to generate the mold to generate necessarily the toolpaths in our definition, even though they started out really similar.
Yeah, at the same time, like we both want to have a more complex approach, but we also want to make it simple enough that you get around the problem of, like, when you're using a computer, I think one of the biggest problems with digital art right now is that it looks a certain way because you're working in a certain way. You have to work in a logical kind of method, and so the things that you make end up looking logical instead of necessarily looking intuitive. So how can we make an interface? How can we work with our tool so that it feels like a material, so that it has a responsive relationship? When you do something, you want to see what happens. You don't want to have to wait however long to know what's going to happen. You don't have, like, how can we work faster in tighter cycles, and how can we actually look at what we're going to get? So making tools that are just very simple. So I guess I can start talking about more of my stuff then.
Yeah, I think that what's going to happen is we're going to run this first plate. This first plate is doing like our original toolpaths.
Yeah.
And then we're going to take you guys to the fringe. We haven't even tested this next code yet. So it may look good, it may not, and it also may work or it may not.
Yeah.
But welcome.
Yeah. Yeah. Welcome to the frontier. So just as a reminder, these are the tools that we're using. Rhino is a 3D modeling environment that it's used just for making different things. You can do anything from, like, a piece of jewelry to a boat or a cityscape, whatever you want to. Grasshopper is this visual coding language. And the reason that I use stuff like Grasshopper, it's parametric modeling is one of the terms that people use. And what it means is you design your workflow without deciding what you're starting with. Like, instead of saying, I want one thing and then I'm going to do this and this and this and this to it, you say, I want some number of things. And so that's your variable or your parameter. And then
That
you
takes
say...
That takes us back to our friend David Pye and talking about a responsive studio practice.
Yeah.
Yeah.
Yeah, so you want to be able to make something so that you can make changes later on. And so you kind of set it up, I'm going to do this, I'm going to do that, and then we're going to do it to all of those things. So I have a slider at the beginning that allows me to change that, and everything will update all at once. And then it also means that instead of doing one thing, I can do like 6 things at once that are all slightly different in some sort of logical relationship. And then the last program here is the one that I use to control this printer. And I control it directly from my machine, which allows me to make some adjustments as I'm working with, again, being able to work responsibly. So my material is not so much the clay or the tools, the stuff that I'm making, but I really think of the program as my material, because what I'm trying to do is I'm trying to build a program that does some kind of new sort of design. And a lot of my work goes into the stuff on the left here, the goofy looking code. But then what I really want out of that is the stuff on the right. I want something really simple so that when I'm actually working on it, I have this ability to quickly go through different versions of that design and make some decisions there. So this is really what my process kind of looks like. Once I have it all set up, all of my work goes into those like 5 things on the left. I make however many different versions of that thing. Then I'll pick one of those, and then I'll kind of take it to the next step in the process. This does have risks. I think that one of the other things that people don't think about with digital tools is just that it's sometimes too fast. One of the real benefits of working in a material or working with clay is that when you decide to do something, you don't automatically have it in front of you. You have this time where you're making it, and making the object sometimes gives you information about it, lets you think about it as you're working on it. And sometimes that can give you a better sense of what you want to make, or a better sense of why you're making it, or what it means. And all of these things are really critical for us making things. And sometimes digital doesn't give you that time, because you get a million different options all at once. And how do you decide what to do if you can do anything, and if there's no cost to it? It's like this paradox of choice. So then I go to this other script, which again has a series of relatively simple inputs, and then that gives me a preview of what my machine's going to do and creates G-code that controls the machine. This idea of a digital workflow, it's going to be like any other process. It's not one direction. For me, a lot of times I'm working, and suddenly I discover, like, that's not really what I want to do, or I really want to do something else, and so I'll go back to that scripting process, and I'll build out a new process. I'll build out a new design opportunity so that then I can get to the point, again, where I'm controlling it in simple ways, and I can work intuitively again. So how are we doing on this?
It has a whole second layer. I thought that we'd probably, can we see some Grasshopper? Can we see that like in motion in this and then come back to this? Or should I cancel it after the first layer and run the second one?
Do some Grasshopper, like make some toolpath kind of things?
I don't know. I think we need to, I mean, we could either run some tiles
Oh, just to like see some stuff
like
happen.
to see, I think that maybe one of the things that might be missing, I don't want to put you on the spot, but I feel like one of the things that might be missing is just seeing like that, like one of those sliders change the design, or how that would like kind of.
Yeah, we can do that.
Yeah.
So that's
Like, let's see Grasshopper.
yeah. Okay, so here's Grasshopper. It's so simple. Like, there's just these little controls right here, and it does everything. Yeah, ignore all of that. Yeah. So there's a little bit else going on here.
So what are these boxes? What are the individual boxes?
Okay, well, just in a really simple kind of explanation, Grasshopper is made up of parameters. I talked about parameters before, parametric design, and components. And parameters are things that, like, it's something that holds something. It's a piece of information. And then a component generally does something. It is another box. And so when we talk about making things with boxes, we're actually boxes inside of boxes inside of boxes. And so this program gives me a whole tool set that's all of these boxes that do this specific thing. When you have a wire going into something, it's an input. And when you have a wire coming out of it, it's an output. And so you know what goes into the box, you know what comes out of the box, but you don't actually have to know what's going on inside of the box. And at a larger level, that's what we're trying to do here. We're trying to make bigger boxes that are more complex, but still have relatively simple inputs. So what does this actually look like? We've got our plate set up right now as our input. So what we do in Rhino, so over here on the left is the Rhino screen, over on the right is the Grasshopper screen. And we've got it set up so it only previews what I have selected right now. Okay, so I've got a plate on the screen, and then I'm going to go over and I'm going to say we want to do a typical offset, and a typical offset would just look like that. It would just be circles. But then if we wanted to start doing the new kind of thing, I changed this to just a little toggle right here. Now we've got a false, so we want to do the other kind of offset. And now we've got this star. And we've got two different variables that we can work with. We can work with the number of points that the star has, so that we can pretty quickly see, like, oh, there's a lot of cool design opportunities here. And then maybe we also want to change the points of that star, how that goes in or comes out. And so we've got a slider here between 0 and 1, and that just subtly changes that design.
It's really interesting to combine, sometimes we think about substrate and surface, like there's form and then there's surface, like they're two separate things. I really love work that mixes them, like that the decorative motifs are like part of the substrate of the thing, like breaking down that barrier is amazing. It's great.
How long does it take to set up the parameters? You have to do a lot of back work so that you have a little.
I mean, this is like, I forget which painter who said, like, how long did this painting take? 40 years? Like,
Yeah.
I mean, it's just a question of experience.
I'm thinking like just the mechanics, like the variables that you're showing us here.
How long did it take this script?
Yeah.
I built this script with you. So most of the script was done, and we had something working. And then it took me maybe like 2 hours to build the new section into it.
So my experience with Grasshopper is a lot different than Joe's, because Joe has like a much wider tool set. Like he understands a lot. I can still make a mess in it. I can still make a lot of cool things. You shouldn't be intimidated, because if you really got into Grasshopper and just watched some videos and read some stuff on forums, you could do cool stuff with it right away. You could make some really great drawings, and it's a really great tool. But Joe's your full-time job for how many years has been dedicated largely to doing this?
This is like 2.5 years now.
Yeah, so I call Joe the Grasshopper guru, because like I can't keep up with him, and I use the space a lot, and I can't keep up with him always when we're navigating that space. So you're bringing a lot into it that allows you to just move real fluidly through it.
I think this is really one of the things that, another thing about the digital medium is, like, it is a medium. You know, it takes you a while to know how to do stuff in clay, so why should you expect that
Sure.
a digital medium is any different? But once you have that level of experience, when you're working on the wheel, you just suddenly come up with an idea of like, oh, I think I want to do this, or I think that's what this is trying to do right now, so I'm going to try and do that. And once you have that level of fluency in any medium, you can start to work intuitively, you can start to work responsively. And that's the point that I'm starting to get to. So like, we looked at this morning and we were like, oh, well, what if we did one layer one way and then another layer the other way, so that when you were looking at the back of it, it was one thing and the front of it was another thing. And like, That'll take me a little bit of time to do the script for, but it's totally doable.
And it all opens up doorways. Like like perhaps this machine could have multiple reservoirs on it and use the spindle on and off that's still open to switch between those reservoirs, and the paths could be multiple colors. So there's like every kind of new thing you kind of figure out. I don't think it's any different than anything. Like every time I go to the grocery store that I have only been to once, the second time, like I know the aisles a little bit better. Like I can find my cornflakes a little quicker.
I think the one thing about it is like the digital medium does allow you to box up actions in a really effective way so that the work can get more complex faster. One of the things just from working in clay, like you figure out a process, but you still have to go through the whole process each time you do it. Where in the digital world, like you figure out the complex process and then you just move on to the next thing and you've got the complex process in your back pocket. I think that's one of the things that causes some anxiety or just is like a little bit weird, because you can look at someone who has very little experience but can still produce a complex result because someone else came up with that solution. And that feels a little bit weird to know that someone can do something that looks impressive, but they didn't do the work to make it impressive. And I think that's a concern that
it goes back to that problem of like, what do you share and what do you not share? What do you take ownership of?
And it's also this like certainty and risk. Like if there's no risk to doing it, like if it was a certain result, do you feel as good at looking at it? It's like, oh, I know how, but like a Voronoi, if any of you have done digital stuff, it's just like, looks like a cellular structure. It looks really cool, but it's so overdone. It's so easy.
Sure. One of the first things I did with Grasshopper was I wish I had it on this PC because it looks really good. It's a simple command, but just to utilize the randomized commands to give it a curve, break it into points, rotate that curve into a pot, and then have it feed me back like 1,000 variations of that, you know? And then you're looking at this possibility where there's not 1,000 necessarily pots that I'd really want to see in the real world, but that puts us in a position where we're kind of curating like the results that the machine is able to kind of quantify for us within a short period of time. Like I don't know how long it would take me to draw 1,000 different like variations of a pot. It would take a while.
I think, do you have a question?
Yeah, you have presented a bunch of code and some scripts. Are these open somewhere? Do you make them available, or is this like special sauce that you're keeping for yourself?
It's a good question about what you share and what you don't. For instance, I have a simple G-code script that I share with students regularly, and if you sent me an email, I'd be happy to share it. But I won't share the whole code that I'm using, but I'll share the code that would allow you to put a pen into a machine like this and make drawings from vectors in Rhino. And the idea of that is that it's a simple thing, and it's in a way that you could read it and use that as a stepping stone, because it's about education. And that's why it's primarily for students. Yeah.
I'm going to ask a question that I think a lot of us have on our minds. I can take a level 1 ceramics class.
Yeah.
And learn how to throw.
Yeah.
But where do I take a level 1 Rhino Grasshopper class? I mean, and you mentioned education is key into getting into this and learning its possibilities, and then struggling with the issues that are involved in it. But can you give us a little advice on what books would be a great entry? What classes are taught and things like that?
It's not just YouTube. One of the big differences about Grasshopper versus other programming languages versus other things is that it is a relatively inexpensive thing. It's got a huge user base in the world, and they've got this awesome website that's got tutorials and a huge community of people who are problem solving. Whenever I have a problem in Grasshopper, I go online and I just go on this website, Grasshopper 3D, and search for it, and more often than not, someone else has had the same problem.
Is there Grasshopper for Dummies kind of thing?
Basically, there is, and that's how I started.
Yeah.
I taught myself everything that I know, like before I started this job. I got this job because I already knew how to do Grasshopper in a really messy way, and I've only gotten better at it because I'm surrounded by other people who are using it.
There's other portals to generating, but as like I'm a really visual thinker. I think you are too, and I think artists really gravitate towards Grasshopper versus some of the other options. I wouldn't say that completely. I know Jonathan Keep uses he uses processing, right? So
Okay.
that's another one. If you're interested in coding and doing script-based things in that way, that's also a free program. The book itself costs $50. And that would be a really great spot if you were interested in that.
And there's a lot of great, I mean, because all of these things are digital, a lot of the information for learning them is also digital. And there's certain ones that are more interested in being open, in sharing information. I think the question about like sharing scripts, I'm not yet ready to, but that's because I haven't made the box well enough.
Yeah.
And it's sort of like if I gave something out and then it broke, and I always had people coming back to me being like, why is this thing broken? I'd rather make something really well and put it out there. The other secret about Grasshopper, if we can go back to my screen for a second, the only things that come with Grasshopper, there's tool sets that are up here at the top. Each of these do something, and so they're a different action, a different component. But the only ones that come with the program end right here. So there's this whole list up here. Everything to the right of this is all stuff that other people have made and put online and made available generally for free. That's what I want to be able to do when I produce these tools. I want to put something out there that works reliably, that is easy to download, that you don't need me to do it anymore. And that's really what the benefit of a lot of this is, and I'm taking huge advantage of other people's work when I do this. The most central component that I use is like this little thing right here. Someone just made this and put it up online, and I use it, and it's the thing. It's that thing I discovered when I
So you
like,
can start
sent you
with
an email.
one curve, and so if this helped make my floors really efficiently. So if you start with one curve that you just drew in Rhino, you can use that to make all the subsequent curves that would fill the inside of it and make a toolpath that you could run on the machine.
And Rhino has a tool that does that, their offset tool. But this one, like if you have two separate regions that get cut off from each other, the Rhino tool will only do one of them, but this one will do both. So it's like nerdy little reasons that this thing is super, super cool. And then it does weird things like we can take a look at the, this other script for, it's just called Weird Offset Curves right now. I made this also just this past weekend, so it looks pretty messy right now. But this one,
I'm going to go ahead and run this second code while you're showing this. We ran one of these last night. Maybe after you guys could come up and see. This is the first run of this code that we just kind of ran yesterday. And we're not completely happy with it, but it's definitely interesting. I'm going to fill the machine. This is the slip. And just to kind of show you what you can get from dispersing and then thickening, so that's the viscosity if it's kind of left alone. It's called thixotropic. We run into glazes that are this way just by happenstance in the lab, and we have to, like things that have Gerstli borate and will often gel. But if you agitate it a little, it runs like a liquid. And that's awesome for pumping because as the pump squeezes it and puts pressure on it, it acts more liquid. And then as it sets in the mold, it kind of gels up and holds its shape.
Can I ask a quick question?
go ahead.
When you guys are having the tip move up and down, I'm thinking about when 3D printing happens and you're trying to keep that stringy nature, your retractions. Is the pump essentially retracting or sucking in as it lifts up so it doesn't drip, or does it just have surface tension that allows it to not drip as it lifts up?
Surface tension. It
So
would be a
just
great idea.
Just to repeat the question so everyone can hear, one of the things that happens in 3D printing is that there's pressure in the extruder that's pushing out plastic. And when you want to move from one place to another, if you're not careful, it will keep on pushing out plastic as you go. But that's because it's basically a pressurized system. This is not a pressurized system.
Low pressure, just the hydraulic pressure, the weight of the fluid, right?
And so when it's not pumping, it's not creating pressure, and so there's no like pressure to relieve when it's doing that.
And I mean, this pump's a little different than some pumps, but basically, I'm working with it because I was able to like get my hands on one and then 3D print some parts and figure it out. It's not like the greatest pump in the world. It just happens to work. It tests these code. I'd love like a big fancy new machine that had like a Moino extruder or something like that. But they all have their own unique quandaries.
Yeah. Yeah, so this is just very quickly, I want to show this tool, and then I want to get into some other things about my machine. So this is now something that's set up, and the feedback that we're getting right here, and we can get rid of this, this is giving us an order of the curves, because we want to know that we're printing from the inside to the outside or the outside to the inside. But then looking at this color preview, it's like, oh, wow, I wish we could do that color scheme when we're printing. Like, that would be totally awesome. But what this essentially does is if you have overlapping shapes, it just creates those offsets. And it's really, really simple. There's a few quirks to the tool, like if you overlap it in some weird ways, then it does bad things. We don't want it doing bad things. So we just have to make sure it's not like overlapping in that way. Like it can overlap in this way, and then we get some cool shapes. The other thing that this script is doing is it's automatically resizing whatever we make so that it's going to be the target size. And then it's also putting it at the center, which is where it needs to be for the machine. So it's kind of taken this process of like, I start with two shapes, I do a bunch of things, and this is where I end up. But it doesn't even have to be just two shapes. Like the way that you get things into Grasshopper is by setting them. So if I go over here and I say set multiple geometries, I've now switched it to those two. But it doesn't even have to just be two. Like I'm going to make this one, I'm going to start changing these, maybe add another rectangle in here. I don't know exactly how this is going to work. Let's make that wider, thinner, and then we'll get rid of that one. And okay, so now we just basically, the only point of this is to make a responsive tool, to make something so that when you're working, you're not bogged down by the interface, by what you're trying to do. Instead, like I think of like with a car, you don't want to think turn wheel, you just want to think turn right. And so this kind of makes it as simple as possible to do what you're trying to do instead of getting bogged down with how you're trying to do it. So I think I'm going to switch gears to talk a little bit more about my machine and how I got into that.
So
okay.
this is the first run. Just real quickly, I guess this is the first run of that code.
How's it going?
It's based off. So far, so good. We don't really know how this is going to play out, but it's going to print 2 layers of it, and I think we can get it on the screen, right?
Can we get that one? Yeah.
There we are. So instead of using the paths, this is a good argument for unboxing that path tool, because instead of using paths that would be really efficient for milling, these would be really inefficient mill paths, but they could be used to mill a pattern, right? I think about David Pye's carved plates all of a sudden now again, too. I guess we'll just see how this runs. Great.
So just a little bit about my machine. This is basically Brian's machine. Brian, are you here? Yeah. So thanks to Brian. He's put up this information like about sharing information. Brian's done a great job of putting this information out there, making it really easy to build one of these. I got inspired at NCECA 2 years ago, and I just spent the summer getting one of these things together. If Brian comes to your school, he'll like build it in a day. But the reason I wanted to use it is because it actually has a nozzle that's really long. And when you're using a regular 3D printer, the nozzle's really short. And what I wanted to do was do this 3D printing in 3 dimensions. When we think about 3D printing, it's basically coil pots. And when we look at the history of coil pots, sometimes you're just doing them flat because you're going to throw them or you're going to like carve over them. You're just using it as a building method. But we also know from ceramic history that it's a really effective means of decoration. Jomon pots, all sorts of stuff like that. So I was thinking, like, why are all these 3D printed pots just using flat lines? I know that it's really reliable, it's really easy, but there's so many design opportunities, there's so many things that could be done if we're thinking outside of that flat planar kind of way. But I quickly discovered that it's kind of like hard and slow and dirty. So instead of printing with clay, I switched over to using a pen. This is actually a brush pen. And it allowed me to do all the same things. So thinking about building this box, instead of using the hard problem of printing with clay, I changed it to a much simpler problem that's basically the same thing. I want to be able to move in 3 dimensions, but I want to do it in a much simpler way. So this idea is not new. There are other people doing 3D printing in 3 dimensions. Some people call it freeform printing. Some people call it wire printing. And then even this idea of drawing with a brush is not something that I came up with. I just got inspired by this guy, Andrew Cudless, who's doing it with a 6-axis robotic arm.
If anyone has a 6-axis robotic arm that they'd like to lend us, you'll see our emails at the end.
So I was able to get some interesting effects just right off the bat. Building some scripts to kind of simulate perspective by using line weight. I taught it to sign my name for me. It signs my name much nicer than I can. And then over on the left, what you see is a pattern that's actually the same the whole way across. What's different is that the bed wasn't entirely level. And so some places it was closer, some places it was farther. And it's this sort of thing where you start to realize that even if you have this ideal design in a digital world, you can end up with something that's very different, that's slightly different, that's subtly different, that's different in all the exciting ways that we want things to be when they come into the world. We want it to be a bit surprising. We want it to be a little bit hard to understand what happened, maybe. And this was starting to do that. But I didn't always want it to do it, or I wanted to control that. And so one of the first modifications I made to this machine was adding a way to make a level bed. So I've just got some screws going through this, some wing nuts that allow me to adjust it on the fly. I don't have that here, so I have little bits of clay that are holding it up. But it's the same thing you do on a wheel. You just got your 3 points of, and then or not on a wheel. It's like when you're like stacking in a kiln. You just do your 3 points of wadding and.
I love not getting hung up on the engineering, like finding a resolution that's quick and making it happen.
Yeah, if it works, it's not dumb.
Yeah,
Something
I
like
use
that.
3 wedges to do the same thing.
They're like door stops.
Yeah.
Yeah. So then the other modifications I started to make was this idea of flexible tooling, of being able to make it do something different, attaching a pen. So this is just like, it's really simple. It's a circle with a point on it, and when you put a pen in there, it kind of has a screw that holds it up against the edge of it. And so you can do different pens of different sizes, and then it's just got a screw on it. This is another thing that I'll talk about later. I'm giving a talk at 1, by the way, about 3D printing and how to do all of this stuff that we're doing, but do it in a really simple way that's like easy and you don't have to learn a whole lot to do it. But one of the things that's really critical is don't try and 3D print everything. So this is a bolt, and bolts are really useful, and they're really standard. So don't try and 3D print one.
Yeah.
They already exist.
Yeah.
But when you want something special, then do that. It makes sense to do something when it's special. But just do the special part. Don't remake the wheel. Okay. So, what does this actually do? Let's see if I can find this. Wrong thing. Where did I put that?
Could we peek at this plate real quick?
Can
It's
we do
kinda
that video
interesting.
3?
Okay, do that.
Yeah, this is what it does.
That's great.
So it's just holding a pen, and it moves really precisely. This Delta is an amazing machine because it moves in 3 dimensions really quickly. Most other machines have like their z-axis kind of moves slower than their x and their y-axis. Like your machine is on a lead screw,
Yeah.
but this machine is on belts, so it can move really quickly in all different directions. That's the other reason to use it. And that's what I do with it. I make pictures. It's a really simple thing, but it's a really cool thing. And this is actually the people from Craneyard Clay. So Belger Craneyard Studios gave me a 2-month short-term residency to do this project. And this was just a show that I was having and that I was doing live robot drawings. These drawings take like a couple minutes each. And that's another thing about the way that I was working on paper with drawings instead of with clay. It allowed me to work through ideas much faster. Instead of being on a week-long cycle or a few days-long cycle, I was suddenly on like a 5-minute, 2-minute, 30-second cycle for getting through my ideas, seeing if things worked, moving on to the next thing. And this is really, the whole drawing is within maybe 1/4 or 1/8 of an inch. It's 3 dimensions, but it's 3 dimensions in the most minimal sense. I get a variation of line width that is useful for a signature, and it's just moving in really precise ways, which is really exciting. It's something that I can't do by hand. So it's like, what is digital going to do for me that I can't do any other way? Zaner is the place that I work. It's also a really inspirational place. So one of the reasons that I got interested in this idea of flexible tooling was working there. This was a project where they took a welding machine that had been sitting in a warehouse not being used, and an intern came in over the summer and figured out how to talk to the machine. And when so this is Shakafa, she's over there on the left. She figured out the code to talk to this machine, and they were like, let's do something with it. Let's figure out like how to poke something. That's all this is. It's a poking machine. They just 3D printed a finger on it, and it pokes stuff. That's all that it does. But it pokes a lot of stuff. And it pokes stuff that's really precise, so it goes to a precise location and a precise depth, and it pokes it. That's all that it does. But it does it so much more precisely than a person could do, and so much faster that we built a building with it. So this is on Roosevelt Island. This is the Bloomberg Center. You can see it now. And it has over 600,000 pokes on it. So I think the thing that I'm pointing to here is just like, this may look like poking, but we're getting ready to do a building or something. Like, who knows what we're going to do with this? This is just the beginning stages. Right after that poking incident, or whatever you want to call it, with this switched over to a different type of machine. This idea of flash manufacturing, of doing stuff really quickly. We had to glue some things, and gluing between the holes on these panels was going to be really hard. So we taught the robot, this is one of my coworkers, spent basically a month, and he 3D printed a tool holder, and he bought a pump system and figured out how to make the machine talk to that pump so that we could glue these lines and just do hundreds and hundreds of lines. But again, just like figuring out how to do things quickly. When you really come down to it, all of digital manufacture is just where to go and what to do. Once you've figured out how to make a machine go to a certain place, then you can really have it do just about anything. This is the new robot at Zaner, and her name is Ruby. And this is the largest pot that I've ever made. It's made out of light, but it's basically a pen holder that we taped on the end of the machine and then did a long exposure photograph of it. I mean, digital manufacture really could be anything. So I now knew, after doing all these drawings, like where to go. But as far as what to do, I was thinking back to grad school, where I was working in the studio next to Liz Sparks, and she was really interested in slip trailing. And I was like, oh, but when I got in touch with Keith and we decided to collaborate, he was like, I'll send you a pump if you want to do stuff with that. And I was like, yeah. So yeah, I'd been thinking about slip trailing, but now I got to do it. So there's a lot in this image, but basically it's how do you take Keith's pump and put it on my machine? And the two things that were critical there, one of them was like, he was like, oh, well, it's got this great bracket system, but I don't have any place for a bracket to go. So instead, it actually turns out that the nozzle on the printer is pretty much the same size as this thing. And so I just kind of first just set it in there. and that worked well enough. But then it was like jiggling around, and so then I decided to weld on plastic parts. So if you see over here, you can see like there's all these plastic welded parts on here. This isn't 3D, well, this was 3D printed. It was actually this box that I had made an extra of, and I cut it apart and just melted it back together around this. That's the other thing, like 3D printing doesn't have to be cool or smart or whatever. It just has to work for what you need it to do. The other thing about this is that I needed some way to attach a nozzle because I wanted to control the size of the nozzle. And so I used this, it's called a lure lock, and it's just like all different syringe sizes that can just twist right onto it. So it's really easy to change out the tool that you're using. And then I started making my own tools. So I wanted to do feathering, and I figured out a good tip for feathering. It turned out to be a brush tip that I was using like for doing drawings. I just cut it down, and then I melted that onto one of these lure lock things so that I could just put it into the machine. Then I had to figure out the pump. The pump's kind of goofy because it's got an on-off cycle, and I wanted to make lines.
So the pump, have you ever seen that little paper catalog that's like American Surplus, Scientific Surplus, that has all the hand drawings of all the little things in it? It's like a bulk mail thing that it'll show up if you order something off the wrong buyer on eBay. But anyway, I bought the original pump that I worked with off of that, and then engineered this from that, utilizing some of the parts of that original pump. But it is an inline peristaltic pump. Peristaltic means that it's just squeezing a rubber tube, and as it's squeezing that rubber tube, it's creating a droplet of the size of the cavity that's in the pump. So how do you deal with that for slip trailing?
Well, when you're slip trailing, you want a controlled line or you want a controlled dot. And the first thing I had to figure out was when it was on and when it was off. So the lines that you see in some of these tests are me just moving it along and extruding it continuously. But it's not like figuring out how long that cycle was, and then you get to a point where you think you know how long it is, but then you don't calibrate it right, so you have to start at the right point. All sorts of like stuff you don't really realize you have to deal with, and stuff that you'll never see if it works out right in the end. Then I also wanted to make dots of different sizes, so I had to like figure out how much to extrude it to make a dot of a certain size. But like once you get to that, then you're actually able to start making designs. And that's where it starts to get exciting. Here I was making so many mistakes that I didn't even bother putting it on clay. I was just using a yogurt lid and just like slip trailing on a yogurt lid.
And you don't have to worry about it drying too fast then.
No, that certainly did come up. So we make baby steps. We go in small increments towards our destination. But baby steps are actually a thing. They're a really important thing. I wanted to be able to control my machine as it was working, because like slip trailing and feathering, they both really depend on having a very precise height. And knowing that ahead of time, that's really hard. So how do you make it just move as you're working? It turns out that it's already built into the code of these controllers, but it's not active unless you make it active. And what you need to do, as I learned after like a week of freaking out about this, is that you just need to delete these 2 slash marks. And when you delete those 2 slash marks, then this option appears in your menu, and suddenly you're able to adjust your machine as it's printing. And you can adjust, on these machines, you can only adjust the Z height, but if we get it working on your machine, you're going to be able to move it around.
Sure.
And it would be on,
presumably on any 3D printer that was using Marlin. So maybe the Lowell's-Bots 3D printers even would have that.
So if you're using one of these printers and you wanted to, say, like make something that intentionally shifted over by a certain amount and then shifted back, or just you wanted to work responsively with your machine to make something that didn't look like it was entirely planned out ahead of time, these are the kinds of tools that you can enable just to make your 3D printer more of a interactive tool.
Yeah, you could print a cylinder, for instance, and you could sit there and wiggle the Z height as it was printing.
Or the XY and get it to like do an offset and an offset back, all sorts of just cool opportunities.
It'd be great to have control of all 3 at the same time.
Yeah, and just like do an Etch-a-Sketch kind of thing. Yeah. So these are the results that I came up with. I've got some of them up here. These are definitely very preliminary, but I think they point to a lot of really exciting opportunities. The precision of it is pretty exciting, being able to do spirals inside of spirals. Also just the unexpectedness of some of the things that happen just with material. I tried to place it so that it was exactly in the middle of these, like a line going across the middle of a point, but you never can get it exactly right. And so I think that the balance of the precision versus the uncertainty of the machine and the result and the tuning, that all makes these a lot more interesting to look at. And it's something that I think digital art really struggles with, is if you know exactly what it's going to turn out as when you design it, then it's almost, it takes the fun out of it. It takes some of the life out of the object if there's no opportunities along the way to make adjustments, to have that risk that's continuously part of the process. Yeah, so I just have a couple other techniques that I've been trying, whether it's laying out a line or making a little app for that. This was a case that I really like how this one turned out, but drying turns out to be a really big issue with this. Just making it stay wet long enough, and then
someone here knows something about that too. Like someone has tried this technique. Like
this is not a new technique.
Yeah.
I believe the English are rather formidable.
Yeah.
And like Irma Starr is this amazing artist in Kansas City, and if I had another 2 months, I would have like called her up and sat and spent like a day watching her. There's so much further to go with this, and really my point about doing this is not that all of you should go out and do slip trailing. It's that this is a machine that moves. We know how to do a lot of things. How can we use these machines as prosthetics, basically? Instead of using them to necessarily replace us, can we use them to extend our own abilities, to do things that we already do, but do them in a different way to give us new opportunities to make things? So I think that's the end of the presentation.
It is. We have 10 minutes.
And I haven't even demoed this. I don't know that I'm going to get to. But,
I don't know. Should we try?
Oh, well, I could try setting this up. Maybe when we just want to open it up for questions.
Yeah. Great.
Do we want to do a mic? No. Okay.
Great.
Okay.
Great.
Sounds good.
One of the challenges, I think, with digital art is it's very deterministic. And you talked a little bit about that by having an interactive adjustment to the printing process. But I wonder if you've experimented with incorporating explicit randomness into your parametric model. And this is the way that a lot of computer-generated drawings start to get fractal forms coming up. Like some of the parameters, have you played around with incorporating explicit random number generators for randomness in your process? I mean, another way you could do it, you could either do it with the parameters of your start.
The problem.
Or also another way is with the drops of your slip, you could have them drop from a randomly determined height.
Sure. Yeah.
Have you experimented with explicit randomness to break down this determinism that I think is really it's kind of interesting at the beginning. Because it's so deterministic, it's a bit boring after a while.
Yeah.
Okay. So just to summarize what I'm
agreed.
summarize what I'm understanding from this
Yeah.
is that because digital is so controlled,
Yeah.
it seems like there's opportunities to use some of the things that it can do, like add randomness or add high degrees of complexity that can make it more interesting. I think there's, from my perspective at least, there's like a plus and minus to that. Random numbers are actually, one of the terms for them in computer programming is pseudo-random, because they're not actually random. They're all a programmed random sequence,
Right.
which appears random, but in my experience, random is actually kind of ugly. And so what what artists who are using randomness typically do is they generate a lot of random versions of something, and then they curate from that.
Yeah.
And so that's still, it's a way to get to something that's unexpected, which is useful. Like, how do we introduce ways of surprising ourselves? But it also is a trap. Like, it can be a trap like any other.
It's almost too easy too. Like it is like I think that there are places within my workflow that I've thought about it and I will, but I'm still at a point where I'm trying to kind of stabilize and understand what's happening, and then I make very few finished projects, so it's like it's really research based at this minute. But there's spaces where I think about using it, but it could be overused really easily. Grasshopper has like a jitter function that would allow you to kind of move the numbers randomly one way or the other, and also random functions that are really easy to plug in. So if that's something that interests you from the get-go too, like you can jump right to that. It could be generated really simply. Yeah.
Okay, so this is my designing tool. I've got 8, 10 different tools in here that I use to make things. I've got the spirograph right there, and then I've got this thing that makes truchet tiles, and this actually does have a random component in it. So I'm going to go down here and turn these things off. I've got something on right here.
One of the things that can break down how digital something kind of looks is like when it moves into the real material, and the way that that material can be problematic. Yeah.
Yeah.
It brings something to the conversation. This thing that's here is not what we looked at on the screen, right?
So here I've got a thing that says add random turns. So now we've got randomness. And then we've got seeds, which is basically different versions of randomness. And it's like, okay, these are all random. These are things that I don't expect. But does that make any of them, how do I decide whether something is good?
You're absolutely right. But
Yeah.
So this is a design problem. In the spirit of not reinventing the wheel, there's randomness, which is just completely random, and then there's randomness contained within structure.
Yeah.
So
Yes.
this is where you can get towards a parameterized, very simple parametric form that will produce a fractal structure of a natural shape or
Sure.
a natural fractal structure. And that, even with just a fractal structure, I think they're quite boring. But when you incorporate the randomness, then you start to get natural shapes, which somehow appeals to our human aesthetic.
Yeah.
There-
Like things that disrupt.
I agree with you. This is an issue that
There's a
does
difference-
deserve
there's a difference
attention.
between that tiling pattern and a wave pattern, like a waves on a water. Waves
Sure.
on the water have a randomized component.
Yeah.
They have a complex component.
Yeah.
What is your question?
Is your split formula, when you get done with that plate, before it's totally dry, can you manipulate it?
Not very much. Yeah, so I haven't, no, not really. It's very not plastic because it has a very small amount of clay in it.
You can't cut it,
But printing into the molds, for instance, here, I could use something with much more clay in it.
Another question. What's your mold made out of?
The mold's made out of plaster.
Okay.
And so the mold's made out of plaster, and it's milled with file that was generated in Rhino so that it had a known geometry.
By different machines.
Yeah, it was a different machine, but the same, is calibrated the same, so it's the same dimensionality, and when I feed it to this machine, this knows where the hole is,
So
you know?
if you were working on a flat surface and bring with plastic clay,
Yeah,
then you could manipulate it.
absolutely.
And you could bring in all the
Yeah.
randomness you want.
And we've talked about this a lot, like, what
Making
about,
parts as opposed to making finished objects.
we need to be able to do more. We want to. And like we've talked about a lot of things. One of the things is, what if the machine's z-axis wasn't controlled by CNC, but instead it was controlled by an optical eye that kept it at a certain height from something else? So what if I could feed it a mold that I'd made by hand rather than a mold that was scanned in the computer, and have it have it actually be able to navigate that space. There's opportunities there. I want to see it.
Software for that. You
You
can
would
make something by hand, photograph it,
sure,
and
sure.
that photo will become a scene.
Sure, sure. But what if it was just, what if the machine itself was responsive to the surface that you put in it and you didn't have to do that? And that's definitely possible.
Yeah.
Hey.
Hey, how do you balance making artwork with this and what seems like an endless opportunity for research and like
Yeah.
delving into areas that don't lead to anything?
I can start that. I'm sure you have something to say about it too. Honestly, like I have decided in my own practice that it's almost like there's two different things happening, and I don't know how they come together. I don't know if they will come together. I'm really interested in using my hands and sculpting and making sculpture, and I haven't implemented this in that side of the practice at all. I'm interested in, I guess the research for me now is to hit this hurdle of what does it mean to use this as a manufacturing tool on the scale of a studio potter and try to make it flexible in ways that it can exist and play in that world. And that doesn't satisfy everything that I need as a maker. Like it doesn't give me everything. Like so I have to do other processes.
I think the way that I'd address it, there's sort of two different issues right there. One of them is how we balance the time that we spend finding out new things and using the things that we already know. And one way of talking about that is the explore-exploit trade-off. Like whether you spend your energy finding out new things, which could be more interesting than what you're doing, or whether you use the things that you know to make something. And those aren't always one against the other, because a lot of times by making something, by bringing it to a finished point, you discover things that you wouldn't know otherwise. And so it's really important to go through that process of actually using it to find out how it actually works instead of how you think it might work. The other side of it is like the making of objects. And for me personally right now, I'm not interested really in making objects. I am really interested in this collaboration that we have going on and eventually being able to hand off the tools that I'm making. I'm personally interested in the design of systems, and for me it goes back to when I first started learning mold making and just figuring out a system for making a certain kind of thing. And once I figured out the system, I wasn't as interested in the things I was making. Part of it comes down to this question of what do you make with it once you have the system? How do you make something that surprises you that you're still interested in? And I think that's a really big question that at some point I'll come back to.
I guess I really hope that with this practice I hope that there's some young students in the crowd that like think about these tools as things that they might implement. And like if someone else had shown me this plate, then I wouldn't have had to see it. I wouldn't have had to make it to see it. And I just really like more people participating with the tools in as flexible ways as possible. And there's limits to it. We wouldn't suggest for a minute that we've got everything figured out. Everything is a baby step, right? Towards like the next thing. And we don't even know what the next question is yet.
I have the next question.
Trevor Bennett.
Hi. First of all, thank you. And really quickly, a bit of a commendation on what seems like a pretty successful collaboration, which I loved hearing you guys talk about, conversing with one another and trying to get things done. That can be kind of challenging, I guess. But it feels like this whole process is intrinsically collaborative with this machine, right? Though I question how collaborative the machine is with you, like how much it's giving you in return, Like I just saw the new Blade Runner, it's a pretty good movie.
Yeah.
So I guess the question, if you could go back to this brief comment you had, and maybe I missed the very beginning of the presentation, about the responsive studio practice.
Yeah.
What is that?
Well, I guess we started talking about, well, I guess when I first met Joe, I was working in a really rigid way. And not to rehash the whole conversation, but when I first came to the Art Institute in Kansas City, like my practice was to draw everything and plan everything out. It's very strategized and try to execute that drawing into a sculpture. And then something happened with the projects, our interaction with George Timmock and the community there. And it's just something that all of us are kind of doing. Like I remember talking to Malcolm Cochran, who's a sculpture professor at OSU, about drawing this. He had a commission for a bronze statue of an elephant. And he couldn't draw the eye just right until he had it in clay and he could poke the eye and move it into place. So it's that, I guess for me it's that, it's like the Grasshopper. It's like parametric, but it can be the studio process with hand. It's that leaving room for the undetermined. And in my own practice, I'm convinced that my ability to see something interesting and kind of bring it out is stronger and more developed than my ability to put it there by intention. So that responsive practice allows the potential of generating something that is more impactful or more complicated, rather in whichever way, emotionally, formally, more impactful than I could have possibly strategized.
I think the way that I'd answer that is as a contrast to what I do between when I'm at work and when I'm at home. At home, I want something that I don't know all the answers when I'm starting, and I'm giving myself opportunities to change things as I go along. At work, we want the exact opposite. The design that I'm given, that I'm adapting, I'm now creating manufacturing files and manufacturing instructions. I don't want there to be any question about what the end result is going to be. So I specify everything at the start because I have to hand it off. I'm handing it off to a different group entirely who's going to be manufacturing on it, and they're handing it off to people who are going to be installing it, and it has to look as close to what I'm designing at that moment as we can get it. We don't want it to be at all responsive. We want it to be directive. And that's just something that's like a very different, it took a lot of getting used to. Like the idea that you have to tell someone exactly how big something is, exactly how many millimeters away from the other thing it has to be, and you have to know all of that ahead of time. It's a different way of working.
Thanks so
Thank
much
you
for
all.
coming.
Yeah.